on that plush
Going live.
couch.
Hey, we're live. Welcome everyone to another session. Oh, I've put Lucas up on screen. There we go. There I am. Welcome everyone to another session. This is obviously we've had our warm-up act now of James Gosling. So now over to the main act, the main man, Lucas Edder. Lucas, how are you doing?
Great, how are you, Simon?
Very, very good, thank you. And you're joining us today from Zurich, right?
Yeah, exactly.
International list of speakers continues. Actually, we should probably get a list of all the different countries and start color coding.
Doing a map
So what's
pin.
happening?
Oh, I've been busy with jOOQ.
Uh-huh.
What's happening on your side?
Well, busy with the VJug as always, and we've got Oliver on the line. Hey, Oliver, how you doing?
Hey guys, I haven't been that busy. No, I think it's great to have Lucas on. When did we first meet Lucas?
I think 1.5 years ago, more or less, at some conference, I guess.
I know we'd been heckling each other online for some time, and I think was it Geek
As
Out in
well.
Estonia when we first met?
Probably.
Yeah, and that's when I realized that Lucas, not even fueled by alcohol, is a tremendous writing talent and humorist and occasional troll. But
Yeah, I'm sorry about
no,
that.
Excellent.
but
So what we're going to do,
all in good taste, I'd say.
I'm going to start the screen share very, very quickly just to show you what we're going to be doing today.
What are we going to be doing today?
Share, let's have a look. Can you see my screen?
Yes.
You can.
Infinite,
Excellent.
Wow.
infinite
Look at that.
regression.
These funky, cool slides. So this is the Virtual Java user group, and coming up today is a session on jOOQ, Get Back in Control of Your SQL by Lucas Edder. And if you wanted to follow Lucas on Twitter, you can follow him on @LucasEdder, and I'll drop a link directly into the IRC chat. Again, thank you very much to our sponsors, Zero Turnaround, the revolutionary developer tools creators. The two tools which Zero Turnaround provide is JRebel, a tool which automatically reloads your code changes instantly, and also XRebel, the new lightweight Java profiler for your Java web apps. And yeah, these guys proudly sponsor our VJug. Today we're going to be running IRC through the Freenode channel #virtualjug, and please do share the group and session because we love new people. We're up to, I think, just over 2,660, 70, something like that. So we are getting super big now. So let's continue to share and continue to mention it to our friends and colleagues to get them on board too. As ever, if you have any feedback, please contact the Virtual Jug at VirtualJug on Twitter, or myself at SJMaple on Twitter. So without further ado, let's pass you straight over to Lucas, sorry, Edder. We also have Mr. Oleg on the tweets today, and we'll be doing an interview with you, Lucas, straight after this session. So if you stay on for that, that'll be made available probably most likely tomorrow with our Rebel Labs roundup, which is going to go onto the Rebel Labs blog. So look forward to that as well. So welcome, and over to you, Lucas.
Thank you very much, Simon. So there's a bit of a confusion already on IRC about how I look. I look differently, apparently, than from Twitter. So this is actually me, just with glasses. I didn't cheat. I'm gonna straight into the presentation now. Today we're meeting to learn a little bit about. I have to screen share, right? I'm doing this for the first time online. This doesn't make sense without screen sharing.
I can see your screen.
Here we go. Perfect. Okay, so today we're going to talk about getting back in control of your SQL. And SQL and Java could work together so much better if we only let them. A little bit about myself. I'm the founder and CEO at DataGeekery. I'm very much of a SQL aficionado. I also love Java. I love these two languages. And when they work together, miracles can happen. I personally believe that SQL is a device whose mystery is only exceeded by its power. And I will talk about this a couple of times in this talk, how powerful SQL really is. So SQL is a very corporate thing. I really need you to read this little announcement in the beginning here. This is our legal disclaimer today. So if you just read through this, you know, normally when I do these talks in the audience, everyone starts laughing, and today I just look at the screen. This is kind of weird, so I prepared something to indicate that you should be supposed to be laughing right now. So there you go. All right. Yeah. I have my own little audience here. So let's talk about SQL. SQL is powerful, and I just recently discovered this again. My reaction when I forget the where clause on my delete statement with autocommit active. Exactly, right? So again, this was a joke. Audience, please. All right. Yeah, SQL is very powerful. It's very mighty, and it's a very, very useful language for production, for productive use, for operations use. And SQL and Java, in theory, should work together like this. So if you have on the left side Java and on the right side SQL, this should be like a jack and a plug, just working together. And in this metaphor, and I'm going to use this metaphor of the electricity throughout the talk, SQL is the data, and it flows into your appliance or application, which is Java. So you have data going out of the plug and into your jack, into your application. But in reality, SQL and Java work together much differently from what I've seen before. So this is much more like it. So I've been traveling a lot in recent times to give this talk, for instance, in Europe or in the US, and everyone knows how this problem relates to them, right? So on somewhere in here we have the Swiss plug and the European jack, and it just doesn't work. So this is practice. And today we're going to look a little bit into the history of SQL and Java. So it all started with this API, and who wouldn't agree in here that this API is a very simple API to use? It has only a couple of types that you have to remember. We have the connection, we have the prepared statement. So you actually create a prepared statement on the connection with a very easy SQL string. Then you can bind variables to that statement before you execute the statement to get a result set. And in the end, you iterate over the result set and get values from it. It's a very easy API, very easy to learn. But actually, there's a naked truth to everything. So today, I'm always going to show the good parts and the bad parts. And in this bad part here, we have a couple of bugs. We have actually 6 bugs in total of this slide. And I would like you, the audience, to find these bugs and indicate them in the IRC channel. I'm trying to make this screen as big as possible. Let's see if this works also on the VJUG. I'm trying to make a very interactive talk. So does any of you find the bugs in this slide? Do you find those bugs?
How many
very
bugs
typical
did you say?
bugs.
How many bugs did you say were in that? 6 bugs.
6 bugs, yeah, you're right. There's 6 bugs.
Okay.
Can anyone find them? You don't have to look too far because they're very typical bugs.
Are we talking proper bugs, or are we talking kind of badly named variables and so forth?
No, it's proper bugs. Actually, stuff that blows up.
Okay, okay.
And they're very obvious things, so it's very easy to actually discover them. So anyone in the audience here knows about these bugs?
Okay, so I've popped it into our C chat now.
Kind of small.
Kind of small. So yeah, you can. That was a screenshot, yeah. So you have to zoom.
It's This is really
one thing I was looking for was the when you do the setints. It's interestingly, SQL is 1 indexed rather than 0 indexed. Is that right?
Yeah, there's something about the indexes. Let's see if someone on the RZ channel has something. Type injection, that's a good thing. So we have this injection here. We have SQL injection. This is a vulnerability, so that's correct. You can't actually just use a type variable and inject it into your SQL statement. That's not safe. You will risk someone dropping your database or doing something else harmful on your SQL connection like that. Very good. Exactly. So we also have Turners who said the text column is not available. So this is correct as well. We have another bug here. So we have a text column. We're getting it from the statement, but actually someone renames the text column to txt. Very good catch. Very good catch. That's a very common issue with JDBC. We don't have type safety. This means that we can't know what kind of columns, what names we're actually getting from the statement. So I'm not sure if this is working properly through the IRC channel. Maybe I just resolved the riddle. What do you think, Simon?
I think so, yeah. Go for it.
Okay, we'll continue. Actually, there are all the 6 bugs right here on this slide. So we have, for instance, on line number 4, we have a syntax error when isAccount is false. So we have the isAccount variable on line number 3. And if this is false, we concatenate an empty string. We concatenate that and connect txt and from, and that will produce a syntax error. Same thing can happen as well on line number 7. So this is not only about SQL injection. If you have a type variable that introduces something like an apostrophe or whatever, you might actually introduce a syntax error as well, apart from SQL injection. And the mayhem continues on line number 8. So if we have isAccount being false, then we don't have the bind variable that is generated only if isAccount is true on line number 3. So if you connect again to line number 3, you see that there is a bind variable if isAccount is true, but the indexes don't change. So that's a really big problem with JDBC. We don't have named bind variables. We only have indexed bind variables. So we always have to keep track of all the indexes when we create dynamic SQL. And then someone on the IRC channel already said there was a wrong column name on line number 14. The column text doesn't exist. It has been renamed on line number 2 to txt. And there's no way we can detect this kind of error on compile time. We only detect these things at runtime. Obviously, on line number 18, we're skipping the other one first. On line number 18, we have close, which is not really in a finally block. This problem has been resolved with Java 7 with the try with resources statement, but it's still very hard at some times to actually get it right when you do have to get it right. When you have the resources being used across various methods, you have to correctly close all those resources, and that's quite hard to get right at the beginning, and you might get it wrong just if you're out of habit. And line number 15 is one of the weirdest ones, actually. We ran into this in production with a customer of ours, and this is a problem that has been introduced in JDBC 4 and Java 6. All those resources like clob, blob, or array, they now have this free method. So in line number 15, we have a clob, we create that from the database, and we consume it, and then we don't free the resource. The problem here is that clobs might have lifespan that is longer than your transaction. They can survive the transaction and still stick around in the connection. So you have to explicitly free them in order for the garbage collector to be able to collect them. That's something that was introduced in JDBC 4, and you didn't know that probably, and you got it wrong, maybe in production. It only happens a couple of times, but when it happens, you have a very difficult to find memory leak. So this is kind of what I tried to say about JDBC. If we go back to the electricity metaphor, with electricity or JDBC, you have to do a lot of work in manual error-prone ways. And it's very inefficient. So these kind of images show you how you work with JDBC. Yeah, I guess everyone can relate to this. So after JDBC, there was something new. We had entity beans and EJB2 and all that stuff in Java J2E back about 10 to 15 years ago. And the idea was that if JDBC is so error-prone and we have to do so much work to write insert, update, delete, and all those statements, we want to stop writing them. We only want to write something like create a new customer request or find a new customer request from the database. And we want to have an API that is very simple. This kind of notion has survived even today. So we write repositories that are similar, like the customer request home interface at the bottom. And we get those entity beans like customer request at the top. And all of those attributes, like text or ID, they might be loaded lazily or eagerly. So that was already invented in EJB2. It's a very convenient API to use at the client side, but it's quite a hassle to implement it at the implementation side. So this was a nice idea, but the naked truth again is this one here. So we have this kind of web logic for EJB2, and I'm going to zoom in here. I'm going to show you about the max beans in free pool, max beans in cache, or something like delay updates until end of transaction. Do you think anyone knows what these XML elements even mean? Probably not. So the problem is, I can tell you, I wrote this for a customer a long time ago. I really didn't know what I'm doing. I really did not know what I'm doing. So the problem here is, it's so complex. I just copy-pasted all that stuff from somewhere, and it probably worked. But does it work correctly? I mean, 500 beans in cache, does that even make sense? 500 beans in 100 beans in the free pool, is that going to create a contention on the server? Will that scale? I don't know. And we have thousands of these entity beans, and all have to be configured individually, and it's so hard to get right. So EGB2 probably, everyone agrees, it's not something that will really miss. So along came EGB3 and JPA, and this was kind of a standardization of Hibernate, which was a very popular framework and still is today. Very popular framework to do object-relational mapping. It substituted EGB2 in the end because it was much more popular and easier to actually do all that work. So when we remember EGB2, we just have those entities and we want to persist them somehow. We don't care about the SQL or the whole insert, update, delete statement stuff. All we have is this entity manager, and we create a transaction on it and persist new events like a conference or after party event. We just persist them. We don't care about how this is persisted, like if it's an update or insert statement, and then we can query them. And we don't care as well if they're in the cache or if they're in the database. We can just query them and get a list of results. And the list is typed, and we get event objects from which we can actually get all the attributes as well. Very easy API. And the naked truth, though, is this one here. The naked truth with EGB3 is we have to have these annotations. And they used to be XML, but now it's annotations, but it's the same thing. All of these annotations, they pose one problem. So you have to imagine you have your schema in your database. You have to write all the DDL to get the schema in the database. And then in the second instance, you have to write all those entities. You have to write all those classes that represent the same schema as in the database. And that's not only duplication of your schema, you actually have a third schema which is represented in these annotations. So the annotations, they're actually the real truth about your schema, the mapping. So everything you can model with annotations will work in your application, but you have to contort your schema in a database or your entity model in Java a lot to actually match these annotations. And this goes on and on with the annotations. So let's see another example. So this is an actual example that I found on Stack Overflow. You got the URL at the bottom, but you will find many of these examples. You probably have them in your application if you're using JPA. So we have all these annotations here to indicate that we have some sort of joint relation between two entities. We have dealers and what's the other? The customer. Probably this is about cars. So we have customers and dealers, and they're related to each other. They have a foreign key relationship. You probably wrote already all the SQL and DDL to model this relationship. Now we write again all the SQL in annotations. So we wrote all these annotations to keep us from writing the SQL. Is that really the brave new world we're looking for? I don't know. But I can tell you something about JPA 3.0 and EGB 4.0. I've had the privilege to talk about with a couple of Java Enterprise spec leads, and I can give you an exclusive preview to what's happening in the next couple of years with annotations and JPA. So this is preview, JPA 3. I'll let you read through this. Yeah, exactly. And this is where this is all going. So we have more and more of these annotations, and more code is written declaratively, not explicitly. And no one knows what all these annotations do and what happens when you combine them. And it's just crazy. And every one of those Java Enterprise APIs will add new annotations that can interact with each other, and it's just so complex. Now this is JPA 3. I'm going to show you what's happening in JPA 4. Exactly. Yeah. Okay. So I'm just trolling a little bit. This has been announced before, so Oliver, I'm sorry about that. if you want more information about annotations, there are a couple of industry experts that are talking about annotations on this URL. Please visit this URL when you have some time and look at the examples again and think about them. And the fact is, I still have no idea what I'm doing with all these annotations, right? So what's next? JPA for developers, what it means is you have this huge framework with lots of complexity that can get hard to manage. It's not actually bad. I'm just trolling here. I'm not really criticizing it. It actually solves some problems very, very well. And those problems are object graph persistence. So if you have your relational model in the database and you want to persist your object model in a very straightforward way, more or less one-to-one mapping, then JPA does miracles. But there are a lot of things that JPA can't do. And if you go back to our original metaphor, some developers actually just wanted this. And note on the right side, I'm not talking about relational databases. I'm talking about SQL. Today we're going to talk about SQL and Java, not relational databases and Java. So if you want to write SQL, your problems should be a lot less than those solved by JPA. And actually, this is what Gavin King himself said all the time. Just because you're using Hibernate doesn't mean you have to use it for everything. A point I've been making for about 10 years now. So if you don't know who Gavin King is, Gavin King is one of the creators of Hibernate and one of the most famous ones, actually. And no one listened to the poor guy. No one listened to him. People use Hibernate for everything now today when they persist stuff in Java. Except some people. Some people thought, okay, I don't get Hibernate. It's too complicated. Maybe SQL altogether is wrong, and we should abandon SQL. And as always, I have also an opinion to this topic. Before we get to that opinion, let's talk about NoSQL and big data. So this is something that someone said in 2009, and he said our service ran at 99.99% uptime in the first quarter of 2009. It runs more than 200 million transactions a day and has sub-second response time. And we're constantly making advances to deliver it even faster. So I don't know if this is big data for you, but it's still quite respectable, 200 million transactions a day. And this was in 2009. This is a very big company. It grew a lot in the last 5-6 years. So I imagine by now they have 1 billion transactions a day or something. By now, you might have wondered who it is, and I'm going to resolve it right now. This is Mark Benioff from Salesforce, and he talks about Oracle. Salesforce database is an Oracle database, and he was a former Oracle employee. They have a couple of nice relationships there between Salesforce and Oracle. In the meantime, they're competitors, but they have been good friends with Larry. And Mark Benioff invented the cloud. So if you think about big data and cloud and NoSQL and all those buzzwords that have been popular in the last 5 years, it's not necessarily about NoSQL. You can do cloud stuff with SQL. Another example is this one here I want to show you. So this company has 300 terabytes of data files for production DBs in total. Quite a bit of data. I don't know, it's average or on the upper end of average. They have a logging database that has 140 terabytes, expected growth at 70 terabytes per year, and a lot of databases for their experiments with 100 terabytes in total. Again, what do you think who said this? This is from a presentation that can be downloaded from the internet from CERN. So CERN is one of the biggest customers of Oracle Exadata, and they're doing miraculous things with black holes and stuff like that that generate humongous amounts of data. And you might imagine that they would store it in something that is more suited for big data, but it's actually also Oracle. I could show you other examples. I didn't prepare more examples today, but one more example is Stack Overflow with a lot of data and a lot of uptime and millions of users, and they're using only 2 SQL servers for their whole application platform. So you have to imagine that those databases, they can actually go scale up very high, and the modern approach to doing all these big data stuff is to actually just put more memory in it. Memory is very, very cheap today, so you can actually scale vertically for quite a while before you actually have to distribute your system again. So NoSQL for big data. You hear these arguments all the time. So NoSQL is not about ACID. You're giving up on ACID. You're giving up on type safety, on standards, tooling, etc. You don't actually have big data problems. That's the reproach that we hear all the time. This is all kind of boring, I think. It's kind of a flame war argument. What I'm really most interested about is this argument here. If you're choosing big data, if you're choosing NoSQL, did you ask operations if they can handle it? That's really a big issue because everyone knows SQL in your operations teams. So, for instance, a bank customer of ours, they know SQL very well. They can manage a large Oracle database on themselves. And if there's something wrong with the data, they just update or insert or something with the database directly. So they can run some statement on SQL Developer and manipulate the data or add a new index or remove one or add a trigger. That's very easy. It's well understood. If they have a NoSQL database on side of it, they don't know anything about it, and they can't actually manipulate the data because the interface is not as powerful as the one from SQL. This is not because NoSQL couldn't get better, but it's still very, very early, and you shouldn't do that to your operations teams in production if you love them. And actually, it goes further than just operations. This particular customer that I'm talking about, even the business analysts use SQL to actually analyze the data they have to write new requirements. So they can check, do we have this data, or do we need a new table for that? Can we easily implement a new requirement, or does this need a lot of data migration? They're skilled people on that level, and it's easy for them to do with SQL because they can access the data directly, bypassing the whole system that has been built on top of the data. So just to wrap up this little NoSQL history, this is a little history of NoSQL. I'll let you read that. I've seen that on a slide of Mark Madsen. It was at the O'Reilly StrataConf. Yeah. So this is the history of NoSQL, right? Okay, let's talk about SQL. We've come here to talk about SQL again. Today we're going to show you a little bit about real SQL. So this is your average transactions table, for instance, in your e-banking system. And what we have here is we have the ID, we have the value date, and the amount of each transaction of the bank account. And now we want to calculate a running total. So what is a running total? It's the balance that we add up for each of these transactions. So these balances are calculated, and how do you calculate them? You could obviously do that in Java, or you could do it in SQL. Now a running total works like this. We take the top balance, and the top balance is equal to the balance below it plus the amount next to it. Very easy, right? That's correct. And the balance below the top balance is equal to the balance even further below it plus the amount next to it. And so on, and this is why we call it the running total. We run through the whole result set and apply this operation all the time. So there are two ways to do this. Either you go from bottom up or from top down, and you can calculate all the balances. This reminds me of Excel. Microsoft Excel works exactly like this. You have these formulas, and you can actually just drag and drop them to apply a calculation to a whole column. So how do we do this in SQL? This is an example of how we can do this in SQL. The whole query would look like this, and if you're zooming in into the statement here, these are called window functions. So many of you might have heard of window functions. Some have never seen them. This is really the biggest takeaway of today. SQL is really awesome, and it is so awesome. It has window functions, and there was SQL before window functions and SQL after window functions. So in order to understand window functions, let's rewind. When we go back to this slide, you see we select from the transactions table. Now, whenever you read SQL, you have to start with the from clause. And the from clause selects data from the transactions table. Then, next step, we filter it with the where clause. So we only want our own transactions. And then the select clause is applied. For every row that is produced from and where, we transform the row with select. You have to imagine this like a Java 8 stream, like a pipeline that produces data from the transactions table and pushes it into the select clause to produce new rows in a new format. So what we take is we take all the columns from the transactions table and this formula here, the current balance that is calculated previously, minus this whole expression. And the expression now And yeah, it has a lot of keywords. That's SQL, right? The expression, it works like this. We take the sum of the amount over this window, and the window is taken using this partition by clause. So partition by means we only take those records in the window that are from the same account ID as the one in the result set outside. You have to imagine we take the whole result set from the from clause and the where clause, and now we transform that with this window here. So we only want to sum up the transactions that are in the same account. Then, once we have summed, we have filtered out the other accounts, we want to order the result set that we have in memory. And we order them by date and ID, the same order by clause as in the outer query. And once we've ordered them, we say, okay, we only want the rows between unlimited before and 1 before the current row. So this is a lot of new stuff if you've never seen it, a lot of keywords. But if you imagine it like this, you go to the 4th row and you have the balance there, which is 19,909.80. And you want to calculate the balance at that row. What you take is the current balance on the top minus the sum of all the amounts that are higher up. Does this make sense? So you take the sum subtracted of all the amounts that are ordered by value, date, and ID, and thus higher up than the current row. So that is the sum that you get over there. This is quite tricky to understand if you've seen it the first time. I strongly suggest read up on window functions. It's really, really very powerful, and all the commercial databases support them, as well as Postgres and also very soon Firebird. You can use window functions all over the place. So don't you think that's beautiful, right? I always say we SQL developers, we suffer from Stockholm syndrome. We love this language, right? Winston Churchill is said to have said that SQL is the worst form of database querying, except for all the other forms. Yeah, actually you don't have a choice. You have to actually use this syntax. You don't have a choice other than using SQL for these calculations when you want to do them in the database, right? So we do some more SQL calculations. Just to do the example. So here we might have a poll that has been recently done. So we have all the number of votes, which is the most popular database abstraction framework. And we got the winner is jOOQ, obviously, and then follow up Hibernate. And we calculate rank and percent. Now the rank is very easy to understand. So we have the rank in this set of data. And the percentage is the percentage of votes of a particular row compared to all the votes. So how would you calculate this? Again, with window functions. And we'll see right away how this works. Now we have the from clause with the poll options, and we just take any poll, assume this is poll ID number 12, and then we do we select text and votes, and calculate the dense rank. So dense rank is the window function that we want to use to calculate this rank. And dense rank will be supplied with another window, and the window takes all the rows that are on top of the rank. So we order by the number of votes descendingly, and we just get the rank. That's very easy to understand. Now, the percentage is a little bit more tricky. We take the number of votes multiplied by 100 divided by the sum of votes over an empty window. An empty window means we take the whole result set, so everything that is produced by the from and the where clause, and we sum it up. So this is almost like an aggregation function. But it is not an aggregation function, it's a window function. You don't have any group by here. And that's the most powerful thing that you have to remember. You can supply different partition by, order by, and frame clauses to all of those window functions, depending on how you want to calculate stuff. You don't have to group by. That's really very, very powerful. Now, today we're going to talk about jOOQ, not only about SQL, but we want to see the Java side as well. So the idea of jOOQ is, if you have this SQL statement, and now you imagine you really want to write SQL, and you want to write this kind of statement, then you have figured out, okay, this is going to work for me, this is the statement I want to write, now I want to write it in Java. And you have one option, it's JDBC. You have another option. You could use JPAs and native queries, but both options suffer from the type safety problems that we've seen on the box slide. If you're using jOOQ, you can just write it straight away. This is the same query with jOOQ. So what jOOQ is a domain-specific language that models all the SQL keywords as methods. If we go back and forth, you see we have select, which is a keyword, and thus it's a method. All the functions are methods as well. So we have denseRank. DenseRank is a function, and this is best modeled by a method in Java. And we have over and order by, and all those things that are keywords in SQL, they become methods. And what else do we see here? We see a couple of items. Do we have a question?
Yeah, we've got one question in from Joshua Wilson, really asking about, I guess, kind of a performance point of view. How much faster is the SQL window function versus running it from Java?
Well, it really depends on your database and on your indexes. So usually you have to imagine. So they heard the question, right? Do I have to repeat the question?
No, everyone's heard that.
Okay.
That's fine.
Perfect. So the difference, the problem here is you have to imagine if these are millions and millions of rows in your database, do you really want to transfer them all over the wire just to aggregate them in Java? So usually the reason why people don't write window functions is because the syntax is awkward and they don't know exactly how it works and they are afraid of performance. That might be true, but you have to imagine that the database might be the best place to do some calculations. It might not, but it might. And for some reports or some use cases, window functions are really the best solution because you don't have to transfer millions of rows over the wire. So you have all the data already available, you have all the index information available, and you can just aggregate stuff. And these are very simple window functions. So if you see things like rank, this is a bad example. So rank is very easy to calculate with Java, but already the percentage. If these are millions of rows and you want to calculate stuff like that and you want to order by percentages, you have to just load all the data into memory. So the answer is it depends. It's not a silver bullet. I hope this is okay with respect to the question. But the window function is just one example. I mean, the idea here is not talk about window functions too much, but about SQL in general. Whatever you want to write in SQL, you can write in jOOQ straight away. And if you're writing your code in Scala, even it's getting even better because the same code with jOOQ in Scala looks like this. In Scala, you can leave out some periods and some parentheses depending on the rules. If you know the rules, you can leave them out. So this looks very, very much like SQL. You can also do symbolic method names, something like the multiplication and division that we see in the middle rows. So if you compare this with the original SQL statement, this is already quite impressive. And most of the time, we actually don't write the code, we read the code. So when you read this, it's much more close to anything else than you could write with strings or with other sorts of APIs. So this is the whole notion of jOOQ. If you have the electricity metaphor from the beginning, if Java and SQL are these, then jOOQ is the adapter in the middle, solving the little bridge that you actually needed to connect the two. So now a friend of mine, Axel Fontaine from Flyway, told me that this really looks, okay, it's convincing, but it's kind of a dinosaur, kind of a Frankenstein example. So I'm showing you a little better example. What jOOQ really is. jOOQ is this one. All right, so this is jOOQ when you talk about Java and SQL. Now, I'm just going straight into the examples now. And while I'm doing the examples, Simon will closely watch the RC channel. You can interrupt me and ask any questions you want. I'll show examples for the next 15 minutes, more or less. Now, before we start with the examples, what we're doing today is we have the Sakilo database. So when we have the Sakilo database, this is one that is freely downloadable from Oracle, from MySQL. There are also ports to other databases. In my case, I'm using Oracle. So the Sakilo database is this database here, really small database that has an actors table, a film table, something like a film actor association table, film category. So you have all sorts of stuff that is in a DVD rental store. Kind of an example database that models all the things that you need when you do relational modeling. Okay, so this is the Sakilo database. And when we select stuff from the SQL database with jOOQ, I'm just quickly going to show you there's a DSL object, and with this DSL object I can start typing. Select from actor, and I run fetch. If I execute this statement, I'm using JUnit to run this, but this is not really important. If we execute this statement, what we see is we see the select statement in the log file, and we see the same again with bind values. Interestingly, there's no bind value here, so it's still logged. And we see the first 5 records from the fetched results. This is the default debug output when you execute a query with jOOQ. So what has happened? How did this work? We have this actor object here. This actor object has been imported. We have a couple of imports here. The most important import is this one. So we import all tables into this demo class. You can imagine this demo class is something like a DAO, where you can just import all the tables from your schema. And the location of the table is really in this class here. So this is a generated class. It has all the tables from your database. Also in Java, every table is generated by a code generator that is shipped with jOOQ to produce a Java class. And in this actor table, if we go inside, when we look at the actor table, what we get here is the columns with all the type information. We have first name columns, last name columns, and we have all the type information here that is necessary to actually access the data. So what happens when we want to select only first names and last names? I can use Eclipse here. So Eclipse will help me with auto-completion. Just type first name. Now you don't have to use Eclipse. You can use IntelliJ or NetBeans or whatever you prefer to type your Java code. But the real advantage is really when you have auto-completion, it's just that much faster. And you save this, and when we execute that again, you can see immediately that only 2 columns are selected. So now we have first names and last names. Again, if you have any questions, just interrupt.
Yeah, couple of questions just in. So Michael asks, how does an IDE do code completion for jOOQ if the select precedes the where?
You actually can't make the select proceed anywhere. So, oh, I get it. The question is the other way around. The point is, okay, this select here is an object, is a method on an object. Now this is a problem. I didn't prepare well. There is no source right now. That is bad. Let's try to find the sources. I'm sorry about this. This will only take a couple of seconds. So, all right. Now, if we go into the select, the type that is returned from the select is a DSL type. So the whole DSL API, if you look at this, if we type F4, let's see if we can find something. So yeah, this is the DSL API. So you have a whole hierarchy of interfaces that model the whole language, the whole SQL language. And if you go back to the code, this select here, it's demo effect. I'm sorry about that. Going back to this code. Let's go into the from. So the from method is something on another DSL type. So we have a select from step. This defines from methods. And the type that is returned from the from method is a join step, which defines join methods. And when you type join, then you have an on step in the end. Something like this, right? On the on step, you have to type on. So the whole SQL language is modeled with interfaces like this. And you can't do anything wrong like that. So if you want to join the film actor table, that's autocomplete. Now it doesn't compile. Why doesn't it compile? We're missing the on step, so we didn't call the on method. Now when we complete it with a predicate, it will compile again. Right? I hope this was okay with respect to the question. I didn't do anything with the where clause. We can add a where clause as well. Something like actor ID greater than, unfortunately this is a big decimal here because it's Oracle. Let's say it has to be bigger than 10. You can't just put the where clause anywhere you want, so you have to be in a place where it makes sense. You can't have a where clause before the from clause. All right. So we've started writing this SQL. We can continue doing stuff like count. Let's say how many films, how many movies did these actors play in? We want to have the first name, the last name of the actor, and the number of movies that they played in. So we already joined the film-actor relationship to get the number of movies. Now we want to group by. And this count doesn't compile yet, but it will compile in a bit. Normally, I also import this type. So we have this DSL type. Eclipse is playing tricks on me. So now, let's just imagine this worked right away with Eclipse. We have the DSL type. Oh yeah, it's a static import. I'm sorry about that. Now we have this count method. All the functions in SQL are methods in this DSL type. If we go into this count method, we have a variety of methods. So we have everything that is possible with SQL. You see a huge variety of SQL functions. They're all implemented in this DSL type for you to use directly in SQL. So going back to this, we have a count method, but now we have to group because just counting doesn't work. So we write this group by, take actor first name and actor last name, copy paste it here, and now we can execute the query again. When we see this, we see the number of movies that every actor has played in, right? This has been straightforward. Now, just interrupt if you have any questions, otherwise I'll just continue.
We've got a bunch of questions if you wanted to take them.
Oh?
We've got a bunch of questions. You're welcome to take them at the end, or I can...
Yeah, go ahead.
Okay, so let's see. So we've got Tom Kez says, can Lucas tell us some experiences when you would use Hibernate over jOOQ, or if there are some experiences when you would consider to switch from something else to jOOQ?
Yeah, that's an excellent question. And we have an answer for that, actually, a marketing website called Hibernate Alternative. We also have a couple of more ranty sites, but this one is pretty objective. There are actually two approaches to using SQL, and in our opinion, and one approach is on the left and the other one is on the right. So the one on the left is domain model centric, so you actually model everything with your domain model. This is in the center of your application. When you're more SQL oriented, more relational model oriented, then you're on the right side. And now we're making some assumptions. Java code drives your database design on the left side. On the right side, however, database design drives your Java code. Which model is first? So in legacy applications, and it's still a very widely used use case, you first write the DDL, you first write your database, because the database will survive all the Java applications. You might even actually access your database from a Node.js application, or maybe a PHP application, or some other application. So it would be very wrong to let your Java code drive the database design. On the other hand, you might have a Java application just persist data in some database, and you don't care too much about the database. Then you're on the left side. You care about your Java code, where all your complex business logic is, and somehow you have to store it. And there are a couple of other features on the left and the right side, and that's pretty much where I'd say on the left side you use Hibernate, on the right side you use jOOQ, more or less. There are a couple of possibilities of mixing both. So CQRS is a model. CQRS, this was first announced by Martin Fowler with this term, I believe, is a model where you write a lot with stuff like Hibernate, with ORMs, and whenever you read and query the database, you use SQL. So whenever you want to use SQL directly, jOOQ is a good choice.
Okay, cool. Another question from Mr. Deviant asks, does jOOQ support non-standard data types like Postgres, UUID, or INET types?
Yeah, we actually just in the recent release, jOOQ 3.5 introduced bindings. So when you go to the manual, the jOOQ manual is very rich. We have about 250 pages by now, and we go to binding. We have an example of custom data type binding that works with jOOQ 3.5 upwards. And in this example, we're using Postgres JSON, the JSON data type, and we bind it to a JSON. Google JSON is an implementation for JSON. You can use any other implementation, and you can just provide a converter to tell jOOQ, okay, the database type here is object. We don't know the database type, and so here we have the database type, and the user type is JSON element. And that's how you convert them from the database type to the user type and the other way around. And with this converter, you have to write a couple of more methods, but they can be copy-pasted most of the time. With this converter, more or less, you can actually just tell jOOQ, okay, you don't have to know how to bind this type of variable to the JDBC driver. I do that for you. So in the end, you can use any sort of data type with jOOQ.
Awesome.
Support is mostly interesting also for Oracle. With Oracle, we have a rich set of features. I'm not sure if this is in scope today. We support all PL/SQL features, all sorts of PL/SQL features with object types and nested table types and all that stuff. So there are a couple of advanced cases that are probably too much for today's show.
Okay, S Moya or Smoya, I'm not sure which it is. In IRC is asking what happens if you remove the suppress warnings annotation. What's that hiding?
Do we have? Okay, let's see. I did this a long time ago. I don't think anything happens. Must have been a previous example. I don't know.
Okay, no worries.
Okay.
Mark H, I'm not sure if that's Mr. Heckler, I'm not sure, from Oracle. How about software houses that rely heavily on routines or sprocs?
Or what?
Sprocs.
Yeah, store procedures. All right. So this is what I was saying before. So here we have an example with stored functions. First off, we go back to the Oracle database. So we are a very Oracle-oriented company. Most of our customers are actually using jOOQ with Oracle. A couple of them are also using jOOQ with SQL Server, but Oracle is by far the most popular database that jOOQ is used with. So here we have a package, an Oracle PL/SQL package with a couple of functions. In today's example, I only have functions. So for instance, we have a getActor function. It takes an ID from an actor and returns an object type. So here we have an Oracle object type, which we can see in this tab here. So the actor type is more or less a duplication of the table, and we also have an in-memory table of actor type. So the rentals package, it also returns a set of actors, or in this case, all actors. So in our example, we're not going to call getActors, but customers, I believe. What we're doing here is we select from this package, and we call the getCustomer function, and we use this customer ID here from the table that we're selecting from. So we go to the customer table, select the customer ID, and pass the customer ID to the getCustomer function. And then we add a predicate. That's not very interesting. And here we have this fetch method. So what happens until here? We just have a very easy, simple store procedure call in a select, embedded in a select. I'm gonna step through this in order for us to see what is happening when we execute this. So we go over to the debug perspective. When we step down to reach the fetch method, we execute the query, and the query looks like this. So here we have it with bind variables, and you see it's just calling the package. That's the first step. The second step is more interesting. What happens when we get back? So here we're using Java 8. We're mapping this single record here. We only have one object. We're mapping that. We're getting the value out of it. And we get this customer object here. And what customer is, we see it right over there. Customer is a generated object with a lot of getters and setters. So this is the object type in the database. And the object type in the database has nested object types. For instance, customer has a getAddress property with a postal code or a city and a country. And when we look at the database again, this maps one-to-one to the customer type, which has an address type, which has a city type, which has a country type. So all of this stuff is also generated, and we can access it type safely directly here from Java. So this is very useful for all of our customers that are using Oracle excessively, also with PL SQL. So this object here has a lot of getters and setters, and once we have, we just printed it out. Once we print it out, we actually want to call second store procedure, where we pass the customer object, which is an object type, again back to the database, and we get another object type back. So I think this is very interesting to explore further in detail on a one-to-one level. Most of the users here probably don't use Oracle that excessively, but actually we support everything PL SQL can do, and in a very type-safe way, actually. I hope this is good for Mark.
Yeah.
Hi, Mark, by the way.
So we've got one from Brendan, or Brendan. How do you design Java APIs for a fluent DSL like jOOQ? Is there a tool that allows you to model all the intermediate steps as Java types?
Yeah, we've actually evaluated a couple of those possibilities, and it would be possible to model a BNF, something like, okay, statement is equal to something, A and B. No, and then you can go down to the select and to the from and everything, and then generate Java types from it. And there are a couple of attempts also on GitHub, not by us, by other people who we've been discussing with, and that works. But the problem with this approach is the API in the end will be not very usable, not very user-friendly. It will be a very technical API. It will be very hard to actually get an API done in a way that is very nice and user-friendly to use. So in our case, everything was done manually. But it is possible to actually generate these kind of DSLs from BNFs. It's just not practical for us.
Okay, another quick question. Let me go and find IRC again quick. Okay, question from Harmeet. Does jOOQ have, I'm assuming this is Maven plugins to generate all classes corresponding to tables?
Yes, exactly. So in this case, I'm using Maven. So this is also I'm using Flyway. So jOOQ and Flyway work together very well to migrate. In this case, everything is migrated and then generated again by jOOQ. So this example here uses the jOOQ CodeGen Maven plugin, but you can also use the code generator in standalone form from Eclipse or from the command line if you prefer. All you have to do is pass this configuration object here with all the information that we need to generate stuff. There are a couple of flags, what you want to generate, what you want to leave out, and the package name of the target directory, more or less. So yeah, and actually even Gradleware themselves, they have contributed a Gradle plugin, so you can also use the Gradle plugin to generate everything for jOOQ.
Okay, cool. Another question from Mark, and it's not Mark Heckler from Oracle, it's another Mark Gates. Is binding a replacement for the old forced types converters?
Oh, so someone is already using jOOQ excessively then? The question was, if binding is a replacement for the old converters. Actually, it's not a replacement, it's an enhancement. So you can still use the old converters. I showed you before these bindings, and you have the old converters here. So a binding actually uses a converter and also allows you to interact with JDBC. What you have here is you can do.
Can you increase the font size there?
All right, no problem. I have to remember that. So before with the converter, you couldn't actually tell JDBC, okay, in fact, this bind variable has to be cast to JSON. You couldn't do that, and you couldn't tell jOOQ to do that. So today you can actually do that with 3.5 and say, okay, if this type is a out parameter from a stored procedure, we have to bind it like this with types varchar or whatever. So the two types, the feature that we used before was the converters only, and binding are enhancements of each other. So the old feature still works and is still widely used.
Okay, awesome. Another question from Hamid. Is it possible to easily, or I guess how easy is it to call SQL functions or stored procedures from within jOOQ?
So one example is when something is built in, you see the example here, it's already built in. You can add an average or whatever function you want. These are very easy. It's also very easy to actually write a function yourself. So let's assume we have a MySQL function, or in the case of Oracle, what kind of function could we use? Let's assume NVL was not defined. NVL is defined, but let's assume it wasn't. Oracle users often use NVL. You write just field of T, NVL, field A, field B. Now NVL is a function. If the first field, the first argument is null, then we want to take the second one. Very easy, right? So what we do is we write field, and we just type NVL, and there's a sort of templating language built into jOOQ. We say, okay, this has the type of the A data type, and then we pass A and B, and then that's it. This was a bit quick. I'm going to tell you again how it works. We take the field A, we take the field B, we pass both these fields as arguments to this template, and we reference them with these template variables, and the whole field has the same data type as field A. Now this NVL here can be used right away in SQL. So this NVL, probably defined twice now, that's a problem. Imagine we call it like this. So this NVL function, now I'm a bit confused. Oh, I need two fields, right? So if there's no last name, I need a first name as well. I went too quickly. So if you execute this statement right now, you will see you can use your custom function right away in SQL. The rendered SQL here is NVL last name, first name. All right.
Okay, cool. One more question from Harmeet. SQL joins. What kind of support is there in jOOQ for SQL joins?
Oh, and we have all support. So no matter what join is the type you want to do, there's join. But if you go to the table, for instance, table type, let's take the latest version. In the table type, you see all sorts of joins. Left outer join, right outer join, full outer join, cross join, natural join, cross apply from T-SQL in SQL Server, and all sorts of other kind of keywords. We also have Oracle's flashback query support and time travel query. So we have all sorts of joins. I showed you how to dereference these join methods from the table, but the same is also possible directly in the select API. So we can change this into a cross join here, if you prefer. Obviously, then the on clause is superfluous, and this will compile again. So in the end, the point is everything that's possible in SQL should be possible as well in jOOQ. This also includes things like aliasing. I'm just going to quickly, before we take the next question, show how aliasing works. Now here we have an actor table, and we want to rename that as A. All we can do now is just replace all the references to actor. We're also replacing all the references to film actor because we have renamed that to FA, and everything still compiles. So the as method that we see here also returns an actor table. So this new actor table also has all the column names because it's the same as this one, only that it's renamed. And when we execute this query, we will see that all the aliases have found their way into the SQL statement. Now, in this example, it doesn't make that much sense, but if you do a self-join or something like that, that's very useful.
Okay, awesome. So I don't see any more questions in IRC at the moment. So if you have any, do drop them in IRC. We're actually at the top of the hour. So is there anything else you wanted to show?
So can I have 5 minutes to wrap up?
Of course.
All right. I'll stick around in the IRC channel afterwards, I guess. Or how do we do that?
No, yeah, you're welcome. You're welcome to stay in IRC as well. You're welcome to do the wrap up here, of course, though.
Okay. Oh, we still have this interview, right?
We do have that afterwards as well. Yeah.
Okay, this was the example. So the point I was trying to tell you today is also citing Mark Benioff from Salesforce, all companies benefit when they can afford to focus on innovation rather than infrastructure. And if you want to write SQL in Java today, without jOOQ, you have a lot of time that you're spending on the infrastructure part. You have JDBC. It works well. It's a very good API, but it's very low level, and you don't want to interact with that low-level API to write SQL. The same is true with JPA's native query API. It's also very low level, and you don't have this SQL integration the way you have it with jOOQ. So we have a vision of better SQL application in Java, and I only showed you a select today. Obviously, you can do insert, update, delete, merge, and all other sorts of statements. We also have active record support, so you don't have to write the SQL statements all the time. When you have insert or update, you can just write store. Usually I show these examples, but today we ran out of time. The interesting part of jOOQ is that it's really a database-first API, so you should use it mostly when database is your center of interest. When your data is more important than the application that you're writing, then you have a database-first design, and then jOOQ has most benefits, but it will work the other way around as well. And there are a couple of other features like SQL transformation and SQL standardization that I didn't show today. Most of your SQL that you generate will work on any database, so what we've executed today is going to work as well with the same API on MySQL or on Postgres on any database. We have support for 18 databases right now, and you don't have to think about the little differences in SQL dialects. And that's a very useful feature for a couple of our customers that are using jOOQ with 6 databases or 7 databases for very complex SQL. Now I'm going to make a shameless plug recommendation. You have the jOOQ discount code for this book to get 10%, but no matter what you want to pay, it's only €9 in the end. It's one of the best books that I recommend to anyone to read from a friend of ours, and it's about proper indexing and performance in popular relational databases. And it's really the 4 things or 5 things that you need to know about indexing that will solve 90% of your problems. It's really something that you should buy on your bookshelf, and it will solve all of your problems. You got the link right there. I've read it, and it's been an eye-opener to myself. So a little last shameless plug about jOOQ itself. jOOQ is free and open source with an Apache license when you use it with open source databases. So that version only works with Postgres, MySQL, and all the other open source databases. We have commercial licenses for use with also commercial databases. That's how we work. And that's it, folks. So if you have found this talk interesting, you can follow us on our blog on Twitter. If you find my jokes interesting, I didn't hear you, but maybe you did. You can follow me myself on Twitter, and you can also sign up on the newsletter where we always bring out new information about SQL or Java, our discoveries, how we design our API, and all that stuff. So that's it, folks. Thank you very much.
Awesome. Thank you very much, very much, Lucas. And you're getting a lot of love in IRC, and Despair is saying he's been using jOOQ in production now for 9 months, and saying how much easier it is than JPA. He also mentions that although you've been talking about Oracle a lot, jOOQ works wonderfully with MySQL and Postgres, and Mark H says they're using jOOQ with MariaDB and MySQL, and the integration is great. Also, thanks very much for all of you being so active on Stack Overflow and your wonderful support. So I think everyone's very appreciative of your efforts as well.
Thank you very much for the summary, and thank you, folks. I love to hear that.
Awesome. So before we close up, just to let you know that we're going to be running an interview with Lucas straight after this. Before I run upstairs and plug my Mac in and it doesn't die, I'm just going to show you what we have running next. So we have on the 12th of January, package your Java EE app with Docker and Kubernetes, and I hope I said that correctly, with Aaron Gupta. Aaron's going to be presenting for, I think, the 3rd time. So I think he's going to be presenter with most sessions on the virtual jug, so that's going to be awesome. And also, jOOQ, this whole session, jOOQ, was actually scheduled because of a request that came in. from one of our VJUG members. So if you have any sessions that you'd like to hear or like to see on the VJUG, do let me know. Ping me on in IRC or on Twitter at sjmaple or at virtualjug, and we'll see what we can do. Also in February, we have a session with Heinz Kabutz. Not exactly sure what the topic's going to be, although I think he has emailed me during the session. So we'll have Heinz on, Dr. Heinz on the 17th at 6 p.m. And we're also looking forward to having the Barcelona Jug join us on that session. So if you have a Jug that you want to have a meetup around a virtual Jug session, get in contact with me as well, and you can be live on the session asking questions in live time as well. So without further ado, then let's wrap up and start our interview, Lucas. Thank you again very, very much for being on the virtual Jug, and it was a pleasure having you on. Awesome, and thanks very much for everyone else for watching on the virtual Jug, and see you next time.